Good morning, mathematicians. This is Lesson 10, Represent Volume with Expressions. In this cool down, we are going to be first creating expressions before we actually go in and calculate for an answer to what the volume of an object is. So our number one in this particular cool down is going to be just to write an expression that can represent the volume of the figure. So notice number one is not give the answer. What's the volume? No, it's not interested in what the answer is. What it's looking for is the expression. And that's really important to remember as mathematicians, because sometimes we want to go right to the answer, but really number one is not looking for the answer. It's looking for an expression. We have to attend to that detail. Just as we saw in yesterday's cool down, we do have a choice for how we divide this particular object up to answer this question, to give the actual partition. And we're going to start with vertically dividing the shape to create a prism on the left, which we will call A, and a prism on the right, which we will call B. So in A, we are looking for what are the three dimensions, because I know I need to multiply those together. Now, luckily, if we do partition this with the vertical line, we do see the three dimensions. We see that we're going to have a length of 4, we're going to have a width of 2, and we're going to have a height of 8. So we are going to have 4 times 2 times 8. Those are the three dimensions. That's what we see when we think about the length, the width, and the height. Okay? Now that is specifically for A. Now let's do some similar brainstorm and thinking, but about B over here. Now B, I'm not seeing everything labeled. I do notice that I have a height of 3, so I know that that is going to be one of my numbers that's going to be multiplied together, but it's not the other two. So let's go ahead and figure out, for example, what is this? What is the length here? Well, I know that this entire line, this entire length is 6, but I only want that portion of it. Well, I can look to a parallel side, namely this one, to determine what the difference is. If this line up top is 4 feet, then I know that this portion of that 6 feet is 4 feet of that. Well, therefore, I would know that this one is 2, because 4 plus 2 is giving us this idea of the 6 feet. So now I know that the length here is going to be 2, so I can go ahead and write that in, but I don't yet know the width. But once again, remember, we can look to a parallel congruent side. So here I am looking for this width measure, and I look over here and I see that that width is exactly the same, and it had a width of 2. So I will come over here and remind myself that the width that I'm looking for is also 2. Now that is for prism B, and again I multiplied the length and the width and the height together to get 2 times 2 times 3. Just like for prism A, I got 4 times 2 times 8. Now I'm going to use that idea to write an expression so that I can represent the volume of the figure below. So I'm going to come down, and first of all, I'm going to take away what I have in blue so as not to confuse. Let's go ahead and focus first on what I have in red down below. Now here we have divided our shape with a vertical line. So if you did the same thing, then take a look. This is what we did as our brainstorm, except in answer form, because I have taken our idea of 4 times 2 times 8, those three dimensions of prism A, in parentheses, and I am adding that to the dimensions of prism B, 2 times 2 times 3. Again, in parentheses, just because I like the look of that. It really separates the three dimensions from the different prisms. Now that is with strategy number 1, which was vertically cutting the figure. Okay? Now, if you did this differently, let's say you horizontally cut yours, that is going to look a little bit different. We are now, just like we saw yesterday, I am going to go ahead and show what that would look like to horizontally cut the shape. And hopefully you did one of the two, but it is good for us just to take a look and see what a different strategy from our peers might be and might look like. It helps us to think flexibly. Notice the difference here. I have horizontally sliced the figure. I'm still going to be thinking about two different prisms, but now the dimensions of those prisms might be slightly different. So I'm going to think about prism A over here. I'm still looking for the 3 dimensions to multiply those together, and 2 of our dimensions are exactly the same. It still has a length of 4, it still has a width of 2, but the height is different. I'm not looking at this entire idea, which the entire idea is 8. I am only looking for what is this portion of it, but I know that this line and this line equal 8. So I know therefore that this has to be 5, because 3 plus 5 gives me 8. Okay, so that's how I know that prism A does have a height of 5. Now that is going to be key to creating my expression for number 1 with this horizontal strategy. But before we get to that, let's go ahead and find the dimensions that we need for prism B. I'm looking for what is the length. Well, I know here the length is 6. What is the width? Well, the width is not labeled, but I am looking at this parallel and congruent width. So I know therefore that this also has a width of 2. Now the height is labeled. This has a height of 3. So now I have the 3 dimensions from my prism B, and I'm ready to take that idea and put it in its final form. I am now writing out for number 1. I'm using my brainstorm to answer number 1 with my chosen strategy. Now this is strategy number 2, horizontally cutting the figure, and the answer that I would put for number 1 would be 4 times 2 times 5, the 3 dimensions of prism A multiplied together, plus 6 times 2 times 3, the 3 dimensions of prism B multiplied together. So that is the answer for number 1, but in 2 different ways. Now I'm going to scroll down because we now have one more thing that we need to do in this problem. We need to actually write out what the volume is. Now before we even get to our number, I'm just going to put a blank for that, because I'm going to remember we're going to calculate the number in just a moment, but whatever our number is, remember that it's going to be feet cubed, right? We could write it as cubic feet or feet cubed, but I already know the unit is feet, and this is volume, so it's going to be cubic feet, all right? Now, I do need to actually find the volume. What is the actual volume of this shape? So once again, I'm going to do a little bit of scratch work. I am going to kind of write over top. This is my final answer for A, or for number 1, but let's go ahead and use this right now to do a little scratch work. I have 8 times 8, which is 64. So see, I multiplied that together. Now I have 64. And here I have 4 times 4, or excuse me, 2 times 2, which is 4, right? And I'm going to multiply that by 3. So now I know that that is 64 plus 12. Now 64 plus 12 is going to be 76. So I now have the answer. It is 76. If I've done my math correctly, when I do the same thing on this side, I should find the exact same answer. So let's go ahead and check. All right, so I have the volume of prism A for strategy 2 being 40. And over here I have 6 times 2, which is 12, times 3, which is 36. Take a look. We have done it. We have an answer of 76 on for both of our strategies, which we should indeed have, because we do want to remember that the volume is not changing no matter what strategy you utilize. What is changing are the particular dimensions of the prism. So you might find, just like we did, that our expressions are different, but they should lead us to the same place. They should lead us to the same overall volume, which is what we see in our answer for number 2. Number 2 says to find the volume of the figure. No matter how you slice it, whether it's vertical or horizontal, this statement is true. The volume of the figure is 76 feet cubed.